What is YAML? YAML's official definition is a human-friendly data serialization standard for all programming languages. YAML's main advantage over other similar formats like JSON or XML is its human readability. That is, it was specifically designed to be easily readable and editable by humans. This makes it very ideal for dual human-machine use cases, such as log files, configuration files, inter-process messages, and in this case, also for Kubernetes config and definition files. Now let us discuss some of the most common use cases as to why YAML files were really created. Firstly, YAML files are used as configuration files, log files, inter-process messaging, cross-language data sharing, object persistence, and even to work on complex data structures. These are the very few common use cases as to where YAML files can be used. Now that we know why YAML was really created and some of its common use cases, let's move ahead and talk about why should you use YAML. Firstly, YAML files are extremely readable by humans. They're very expressive and extensible. Even a small child going to school, if you show him or her a YAML file, they could identify few things and how the structure is completely laid out. It's really that easy. And the second reason as to why you should use YAML files are because they're very easy to implement and use. The third benefit is that they're easily portable between programming languages. So if you want to switch from one language to another, if you want to create these YAML files in Java, for instance, you can easily port this YAML file to Python. Okay, so it's very portable, and that's the biggest advantage of YAML files. The next advantage is they match the native data structures of agile languages. So that's another advantage. That is why porting between programming languages is also possible because it matches the native data structures. The fifth important benefit is that you can perform maintenance. You can really maintainability among these files are extremely easy. The last advantage is that they are flexible. Now let's move ahead and talk about the structure of a YAML file. There are three building blocks of a YAML file. The first one is a key value pair. The second one is arrays and lists. And the third one is dictionary or map. The basic type of entry in a YAML file is of a key value pair. After the key and colon, there is a space and then the value. List, on the other hand, would have a number of items listed under the name of the list. The elements of the list would basically start with a dash. They can be a number of lists. However, the indentation of various elements of the array matters a lot. Dictionary or map, on the other hand, is a much more complex type of YAML file, which is a much more complex type of YAML file that would be a dictionary and a map. Now, let me explain this with an example. Key value pair could be fruit colon apple, vegetable colon radish, liquid colon water, meat colon goat. Arrays would be a group of similar items, like fruits would be orange, banana, mango, vegetables would be potato, tomato, carrot. Dictionary or map would be how these items within an array or list are classified. So banana can have three features that are calories of 200, fat of 0.5 grams, carbs of 30 grams. Grapes, on the other hand, could have calories of 100, fat of 0.4 grams, and carbs of 20 grams. So once the structure of a YAML file is clear, let's move ahead and talk about some of the basics of YAML. So as you can see, it is difficult to escape YAML if you're really doing anything related to many software fields, particularly Kubernetes, SDN, and OpenStack. YAML stands for yet another markup language, which is a human-readable text-based format for specifying configuration type information. So usually when you're learning anything about Kubernetes or anything related to deployment, you would first learn how to create a pod and then a deployment, right? So when you're defining a Kubernetes manifest, YAML gives you a number of advantages that includes convenience and flexibility. Firstly, you will no longer have to add all your parameters to the command line. When defining a Kubernetes manifest, YAML gives you a number of advantages, including convenience, maintenance, and flexibility. So in terms of convenience, you'll no longer have to add all your parameters to the command line. And when you talk about maintenance, YAML files can be added to source control, such as a GitHub repository, so you can track your changes. In terms of flexibility, you'll be able to create much more complex structures using YAML than you can on the command line. YAML is basically a superset of JSON, which means that any valid JSON file is also a valid YAML file. So on one hand, if you know JSON and you are only ever going to write your own YAML, you're all set. On the other hand, that's not very unlikely, unfortunately. Even if you're only trying to find examples on the web, they are most likely non-JSON, that is YAML, so we might as well get used to it. Still, there are many situations where the JSON format is much more convenient, so it is good to know that it is available to you. Fortunately, YML is relatively easier to learn, and there are only two types of structures you need to know about it. The first one is list, the second one is map. That's it. You might have maps of lists and lists of maps and so on. But if you've got those two structures down, you're literally all set. That's not to say that there aren't more complex things to do, but in general, this is all you need to get started. So let's move ahead and talk about YML maps. Let's start looking at these. Maps really let you associate name value pairs that we have already discussed, which of course is convenient when you're trying to set up configuration information. For example, you might have a config file that starts like API version v1 kind as pod. The first line is basically a separator and is optional unless you're trying to define multiple structures in a single file. From there, as you can see, we have two values, v1 and pod, mapped to two keys, API version and kind. This kind of thing is pretty simple, of course, and you can think of it as in terms of JSON equivalent API version as to one and kind as pod. So in the YML version, the quotation marks are optional. So in the YML version, you don't really have to add the quotation, it's optional. The processor can tell that you're looking at a string based on the formatting. You can also specify more complicated structures by really creating a key that maps to another map rather than a string. In this case, we have a key, metadata, that has as its value a map with two more keys, names, and labels. Okay, the labels key you can see itself as a map as its value. You can nest these as far as you'd like to. The YML processor knows how all of these pieces relate to each other because we have intended the lines. In this example, we've used two spaces for readability, but the number of spaces doesn't really matter as long as it's at least one and as long as you're consistent. For example, names and labels are at the same indentation level, so the processor knows they are both part of the same map. It knows that an application is a value for labels because it's indented further. One thing you'll have to know is never use tabs in a YML file. So you could imagine the JSON file of this, right? So I hope maps are clear. So now that we've understood about maps, let's talk about YML lists. YML lists are literally a sequence of objects. You can see this example. We have arguments sleep, 1000, message, bring back Firefly. You can have virtually any number of items in a list, which is defined as items that start with a dash indented from the parent. And of course, members of the list can also be maps. So in the JSON file, this would be arguments sleep with quotation, 1000 with quotation, message with quotation, bring back Firefly with quotation. And of course, members of this list can also be maps. So you can have list of container objects, each of which really consists of a name, an image, and a list of ports. Each list item under ports is itself a map that lists the container port and its value. So now that we know maps and lists quite in detail, let's move ahead and talk about YML usage in Kubernetes. So having seen the advantage and basic building blocks of a YML file, let us understand how YML is used in Kubernetes. The Kubernetes resources are created in a declarative way, thus making use of YML files. Kubernetes resources such as pods, services, and deployments are really created by using the YML files. The example here contains both basic and advanced specifications. Firstly, let us talk about the various fields that are available. The first one is replicas. This tells Kubernetes how many pods to create during a deployment. Modifying this field is a very easy way to scale a containerized application. The second one is in spec strategy type. So suppose there is another version of the application that needs to be deployed, and during the deployment phase, you need to update without facilitating an outage. The rolling update strategy allows Kubernetes to update a service without facilitating an outage by proceeding to update pods one at a time. Again, under spec, under strategy, you can see max unavailable. This is the maximum number of pods that can be unavailable during the rolling update. Also, the max surge option gives you the maximum number of pods that can be scheduled above the desired number of pods. Now, again, in specification, you can see minute ready seconds is an optional integer that really describes the minimum number of seconds for which a new pod should be ready without any of its containers crashing for it to be considered available. Revision history limit is an optional integer attribute that you can use to tell Kubernetes explicitly how many old replica sets to retain at any given time. Under metadata labels, you can add labels to a deployment specification, whereas the selector under spec is an optional object that tells the Kubernetes deployment controller to only target pods that match the specified labels. Thus, to only target pods with the labels of application and deployer, you can make the following modification to our deployment YAML. You can see from the explanation of the various fields that YAML files can really help you maintain and control Kubernetes resources in a very declarative way. YAML is on its way to be considered as a de facto standard for configuration files. So in the next part of the session, let us learn how to create a pod using YAML. Okay, so now what we're going to do is we're going to be creating a Kubernetes pod using the YAML file. There are some prerequisites. You will have to have kubectl and minikube installed on your VM. Okay, so currently I'm working on my Linux virtual machine and I already have my kubectl and minikube installed successfully. To check if kubectl has been successfully installed, I'm just going to execute the command kubectl version space dash dash client. This will just give me an idea if the kubectl client version has been installed successfully, and you can see that there is the version info, the git version, git commit, go version, etc. So we know that kubectl is installed in my VM. Now, if you want to start the default minikube cluster, all you have to do is execute the minikube start command. For this, I'm just going to type minikube start. This command will automatically start the minikube cluster for me in less than a minute. Now that we have successfully configured our minikube cluster, so what we can do is we can just clear the screen and let's move ahead and create our YAML file. So the first thing that we're going to do is we're going to learn how to create a Kubernetes pod using the YAML file. Now to create a Kubernetes pod with this file, you first need to create an empty file and assign it the necessary access permission, and then you define the necessary key value pairs, that is lists. The important lists are the API version, the kind that is basically the pod, its name, and the containers that are present within the pod. So now what we're going to do is we're going to create a file that is named pod1.yml. Okay. So now what we're going to do is we're going to code the YAML to create a pod that has been named new pod. So first I'm going to specify the version. The API version is v1 and the kind will be pod. The metadata will specify the metadata. Its name will be new pod. Labels. The labels will be app and environment, and this will be test. Once that is done, we're going to execute the specification. Here we have containers, and here the name will be test container and image will be nginx. I'm just going to specify a dash. I'm just going to save this file, and once I've saved, I'm just going to use the kubectl apply command pod.yml. So you can see that there's a new pod that has been created, and once that is successfully executed, you're going to get new pod has been created. So now to see the state of the pod, if it is up and running, we're just going to execute the kubectl get pods command, and you can see that there are many pods that have been created in the past. So you can see that the new pod has been created 27 seconds ago, and its status is container creating. Okay. After some time, if you execute the same command, you can see that the new pod is in the running state. So basically, this file is really important. Taking it apart one piece at a time, we can start with the API version. Here it's just v1. When we need to get to deployments, we will have to specify different version because deployments do not really exist in v1. Next, we are specifying that we want to create a pod to hold our application or cloud service. We might specify instead a deployment, job, service, and so on, depending on what you're trying to achieve. Moving on, we specify the metadata. Here we're specifying the name of the pod as well as the label we'll use to identify the pod in Kubernetes. Okay, then we will finally configure the actual objects that really make up the pod. Okay, the spec property includes any containers, memory requirements, storage volumes, network, or other details that Kubernetes needs to know about, as well as properties such as whether to restart the container if it fails, etc. All of that specifications can be mentioned here. So we have a fairly minimal definition here, that is a name, that is the front end, and the image on which it's based on, that is Nginx. And if you want to mention one port on which the container will listen internally, you can also mention that. You can also move ahead and specify more complex properties such as a command to run when the container starts, arguments it should use, a working directory, or whether to pull a new copy of the image every time it's instantiated. You can also specify when deeper information such as the container's exit log, all of that can be specified here. So now that we have finished the first part and created our first pod using the YAML file, let's move ahead to the next part of the session. Okay, so now what we're going to do is we're going to be creating a deployment using the YAML file. So let's quickly switch back to our terminal and get started. So now what we're going to do is we are going to run an application by creating a Kubernetes deployment object, and you can describe a deployment in a YAML file. For example, a YAML file can describe a deployment that runs the Nginx 1.14.2 Docker image, right? So that's what we're going to do. We're going to create a deployment. So I'm just going to clear my screen. So what I'm going to do is I'm going to name this as deployment.yml. Okay. And once I create this, I'm going to just add all of its fields, right? So firstly, I'm going to add the API version, that is apps/v1. Then the kind will obviously be a deployment. Then I will specify the metadata field. Here I'm going to specify its name as Nginx deployment. Once that is done, I'm just going to mention the spec. So here I have the field selectors and then match labels under it. And the app here is going to be Nginx, right? Okay. After this, I will set the replicas to 2. So what this really does is it tells deployment to run 2 pods matching the template. And now I'm going to specify the template field. Under this, I'm going to specify the metadata field followed by labels. And here we're going to specify the app again, that's Nginx. I'm going to give specifications to the containers. And here the name Nginx, image is going to be Nginx 1.14.2, and the ports, and then under the ports field we're just going to specify the container port, which is 80. Once we've completed writing the code in the YAML file, what we're going to do is we are quickly going to save this file, and we are going to create a deployment based on the YAML file, right? So for this, I'm simply going to use the kubectl apply command. With the help of the F flag, I'm just going to create this deployment, right? So let's do it. You can see that the deployment has been successfully created. You can also, really describe this information, right? You can display the information about the deployment by using the kubectl describe command. So I'm just going to describe the deployment, Nginx deployment. And you can see that the output is available. You can see its name, that is the Nginx deployment. You can see the namespace, it's been created in the default namespace, the labels, if there are any annotations, the selector, the replicas, there are two right now, and the strategy type is rolling update. All of the detailed information about this deployment has been given or described after this command has been executed. So once that is done, what we can do is we can also scale the application by increasing the replica count. For this, you can also create a scale YAML file and then apply the new YAML file, then verify that it has pods. So if you want to check out the number of pods that are currently present in the deployment, what you can do is you can use the kubectl get pods command. Okay. And you can specify the L flag, assign app to Nginx. So you can see that I've created two pods, right? That is 2 minutes ago, 2 minutes 30 seconds ago, and the status is running. That's great. So this is up and running, we know that. So now what you can do is we will clear the screen and we will check our pods IPs. Okay. So now what we're going to do is we're going to use the kubectl expose command, and we are going to be exposing the deployment that we've just created. And the deployment name is Nginx deployment. So that's what I'm going to mention. And you can see that the Nginx deployment, that is the service that we've created, has been exposed successfully. Now, what I'm going to do is I'm going to open the service file, the service.yml file, using the vim command. So I'm just going to write the code. So firstly, we're going to specify the API version, that is v1. Then I'm just going to mention the kind, that is service. So this is a service file, so that's the kind. And in the metadata field, so I'm just going to mention the various tags that's associated. First, we will write the name. The name will be Nginx deployment. Then we have the labels, and under this, we have to specify the run tag. Here, we're going to specify Nginx. Then in the specifications field, we are going to mention the ports. And under this, you can see that the port we're going to specify is 8080, followed by the protocol, which is going to be TCP. And in the selector field, we're going to specify the run tag. And this also will be Nginx. I'm going to save the service file. So once it's done and saved successfully, so using the kubectl get command, so we're just going to see the list of supported fields in the service definition. And my name is Nginx deployment. So that's what I'm going to really work on. So you can see that you have the type, that is cluster IP, the IP address is given, the port is 80 TCP, the age is 9 minutes 28 seconds. So you must be aware that a service is backed by a group of pods, and these pods are exposed through endpoints. The services selector will be evaluated continuously, and the results will be posted to an endpoint object, which is also named as Nginx. When a pod dies, it is automatically removed from the endpoints, and new pods matching the services selector will automatically get added to the endpoints. And if you want to check the endpoints and note that the IPs are the same as the pods created in the first step, we can just use the describe svc command and check it out. And you can see that the name is Nginx here, namespace is default, the app is equal to Nginx. You have the selector, all of the information is given here. And the endpoints is 172.17 and so on. Now we're just going to execute the get command. You can see that both of these endpoints are the absolutely same, right? The Nginx and the service that we've created. Now we should be able to curl the Nginx service on the cluster IP port from any node in your cluster. So now I'm just going to clear my screen. So this is all you have to know to get started with the Kubernetes YAML tutorial. Okay, so now what we're going to do is we are going to be deploying a service in an application. So for this, firstly, what we have to do is we'll have to create a YAML file, and I'm just going to create a deploy.yml file. And as you can see, the file opens. So here I'm just going to type out the entire code. So you can run an application by creating a Kubernetes deployment object, and you can describe a deployment in a YAML file. So now let me explain this code, okay? We start with the API version. Here it is apps/v1. So next we are specifying that we want to create a deployment to hold your application or service. We might specify instead a job, pod, service, and so on that we already know, depending on what we're trying to achieve. Next, we specify the metadata. Here we'll be specifying the name of the pod as well as the label we'll use to identify the pod to Kubernetes. And then we will configure the actual objects that make up the pod. The spec property includes any containers, memories, replicas, all of that. So here we have a simple, fairly minimal definition and name for the spec container. In the spec property, we have containers. That is a name and an image and different ports. You can also specify more complex properties such as a command to run when the container starts, arguments it should use, a working directory, all of that. Okay, and then moving on to the next part, we add 3 dashes, and then in the next part, we'll mention the service. So you can see that the API version is v1, the kind is service. We're creating a metadata where the name of the metadata is Nginx. And using the spec property, we're going to specify the type, which is node port, a selector where the app is named node port, and ports by default and for convenience, the target port is set to the same value as the port field. So the port is set to 80, the target port is also set to 80. And we also have an optional field. For convenience, the Kubernetes control plane will allocate a port from a default range. So the node port here is specified as 3007. We're quickly going to save the file. Now that we've talked about the YAML file in detail, let's go ahead and save this. Now, once the file has been saved, let's use the kubectl apply command. You can see that the deployment and the service has been created. And what we're going to do is we're going to use the kubectl get server. And you can see that Nginx on port with cluster IP 10.99.84.28 has been successfully created, and it's been deployed on port 30007. So what I'm going to do now is I'm going to open a web browser. I'm just going to add the external IP on which my instance is running on 30007, and you can see that the application has been successfully created. You can see that there's welcome Nginx and there's some more details that has been given. So just by creating one YAML file, we can add the application and the service and deploy it all together. So this is how easy it is to work with Kubernetes using YAML.